Hey guys, Mr. Sheelan here. This is going to be the video concerned with just the check your understandings for the Unit 6.1 notes concerned with waves, where we are looking at the properties of waves, the parts of waves, and then just two different types of waves, longitudinal and then transverse. So just make sure if you haven't gone through the notes already and filled out the notes, make sure you do that first and then come back and then complete these check your understanding. Okay, so which one is a transverse wave and which one is the longitudinal? So remember transverse, we could almost think like transverse is like this, where here's the T for transverse. Here's the T for transverse. These are waves that move up and down and also back and forth, if we want to think of it that way. Okay, they move specifically perpendicular to the motion of the waves. So the waves are, let's say, will move this way. Well, it moves perpendicularly, meaning it'll go up or it'll go down if it's moving this direction. So which one does it do here? Well, I'm going to say B. So B right here is going to be my transverse wave. And I see that because here I'm seeing that these waves are going to basically, like these waves are almost seemingly bouncing up and down, but also moving in this direction. And that's going to leave A here to be my longitudinal. Now longitudinal waves here, they just move more or less just back and forth. They move parallel with the motion of the waves. So what we get here is we get these little chunks that we call compressions. Okay, we see these little chunks called compressions, and then we have these stretched out areas that are called rarefactions. Okay, so we see these compressions and rarefactions in longitudinal waves that tell us, how fast or how many times a wave passes through a particular object that shows a longitudinal wave. Okay, then check your understanding number 2. So which one is the transverse wave and which one is the longitudinal wave? Okay, so sound waves are an example. They are examples and great examples, ones we'll get into in 6.2, of longitudinal waves here. So here again we've got compression, we have refraction here, there's like this gap right here, okay, as these are like air molecules, these are molecules in the air. Okay, here we see as the waves are going by, they're making these areas where there's like all the particles are spread out at the compression points, they're coming together. So here we have a longitudinal wave in the form of sound waves. And then here we have just a picture of the electromagnetic spectrum, and the electromagnetic spectrum takes advantage, or at least we represent it, and it moves in such a way like transverse waves. Okay, so here sound waves, longitudinal, electromagnetic spectrum. We use transverse waves to translate how the waves move for the electromagnetic spectrum. Okay, so number 3 and 4 for the check your understandings. This is where we're going to use these wave properties and also the wave properties / equations. We're going to use that, but 3 and 4 specifically are going to look specifically at frequency and period and help you understand, well, if you're given one and you need the other, how do you find it? So let's take a look at number 3. It's to say that it takes 3 seconds for a wave to go by. What's the frequency? So remember, period is how long it takes for something to complete a particular task. Okay? So in this case, it's saying that it took 3 seconds for one wave to pass by a particular position. Okay? So we'd say here that our period is equal to 3 seconds. Okay? But the question is asking, what's the frequency? We need to know what the frequency is. So again, period is how long it takes for one thing to happen. Frequency is how many times something happens in a second. So what's really cool about this is that, and hopefully you kind of hear it, period and frequency are pretty closely related. Again, how long it takes for a thing to happen, how many times a thing can happen over time. So a period question would be like this. It'd be asking how many hours are in one day. Well, of course, we know that there are 24 hours in one day. Okay, that's a period question. How much time goes into this one thing? A frequency question would be like this. It would be asking, how many times do you go to school per week? So what you're asking is, how many times do you go to school in 1 week? And for most of us, it's 5. We attend school 5 times for every 1 week. That's a frequency question. So here it says it takes 3 seconds for a wave to go by. Now it's asking, well, how many times does it go by in a second? So all we do is we say this. Well, we've got period. We need to find frequency. Well, frequency is equal to just 1 over t. The reciprocals, okay? By reciprocals, because all it is, because again, period is time divided by, the one thing that you're doing, or the task, where frequency is it's the number of times you can do the thing excuse the bell. So it's the number of times to complete a thing, or number of times that you completed the thing, divided by 1 second. Okay? So they're just flip-flopped. That's all they are. So if we need to find frequency and we're given period, we could just find it like this. Period is equal to 1 over period, so then it'd be 1 over 3, which then will give us a frequency here of 0.33 repeating hertz. Those are the hertz is the things per second, the things per second units that we give that I go through in the notes before. Okay, so there's 0.33 repeating hertz. Okay, so let's try this again. So a runner's legs go back and forth 16 times in 10 seconds. What's its frequency? So here, now we have the number of times the thing happens and then some time. So how do we find the frequency? Well, frequency has been given to us here. Frequency would be, again, it's the number of times thing happens divided by time. So here we've got time, and the time's 10 seconds. And in those 10 seconds, we saw the runner's leg go back and forth 16 times. So it's easily going to just be 16 divided by 10, which is then going to give us a frequency of 1.6 hertz. Or you could say 1.6, I don't know, 1.6 legs per second. Okay? And we have our frequency. So again, it's really just to show what, and to exemplify what frequency is and to explain what period is. Remember, again, period, how long does it take for a thing to happen? Frequency, how many times does that thing happen in a particular amount of time? Because you can have frequency, like the frequency question, you could have it in seconds, in hours, in days, but usually we do just go by seconds. So the number 5 and then number 6 we're going to do here. That's all we've got left. So a fisherman, now this one's where we're going to actually do some actual calculations here. A fisherman noticed that a float makes 30 oscillations in 15 seconds. He also noticed that the distance between the 2 consecutive crests is 2 meters. What's the wave speed? What's the wave velocity here? So we've got a whole lot of things to unpack here. So 30 oscillations, that just means that we saw a wave produced, we saw 30 waves produced in 15 seconds is what we saw here. And then here it says that we have a distance between 2 consecutive crests, which those consecutive crests, this would be our wavelength, is 2 meters, and it's asking for wave speed, its velocity. So we've got this. We've got the wavelength, our lambda. 2 meters. Okay, that's what this little symbol is. It's lambda. Okay, this is a symbol indicating wavelength. Our wavelength is 2 meters. We've got this weird thing here, 30 oscillations per second, or per every 15 seconds. That sounds like its frequency. which it would be. So it's a 30 things that are happening in 15 seconds. So there were 30 oscillations in 15 seconds, which really is just going to give us a frequency of 2 hertz. That's what it is. There's 30 divided by 15 will be 2 over 1. There's 2 oscillations every 1 second. Okay, so our frequency is 2 hertz. And what we're trying to find here is our velocity. We don't know what the velocity is. Okay, so we're going to use these two in order to find the velocity. Now, before I do that, though, just to kind of give an idea of what's happening, this is what this guy's seeing. So a fisherman's out on his boat, and he sees this buoy, or he sees this floaty thing, and I'm going to draw it like a buoy that we see in like a river, or like on a, I guess not a lot of lakes have these, but like these buoys that you see floating around in rivers mainly. Okay, so what this guy saw is that he saw this buoy. Okay, he saw this buoy in the waves, and it was bouncing up and down. Okay, it was bouncing up and down. And what he noticed was that when it was bouncing up and down, he was able to calculate, you know, he could make almost like a wave out of it, almost as if he saw it moving in this direction. He was able to make waves that look like this. Okay, focusing on this guy. And so what he saw was that the distance from here to here, this wavelength, was 2 meters. Okay. What else did he notice? He noticed that it took, in order for, say, this one whole wave to pass by, it took roughly about, he saw 2 of these pass by in 1 second. So it was bouncing up and down pretty good. And he wants to know, well, how quickly are these waves that are pushing this up and down, how quickly are these waves moving? And that's what we're trying to find out here. Okay. And so he then would have to do this. Velocity is equal to the wavelength times the frequency. Okay, so that's going to be our 2 meters times 2 hertz, which is going to give us a velocity of roughly about 4 meters per second. Okay, so roughly speaking, these waves, so if we were to follow, like, say, even, we'll say these water waves, like, if we were to take a picture, or we were to track this, the energy of this wave moving through the water, that means that this one guy is moving around like 4 meters per second across the water. Okay, that's what we'd be seeing. Let's take a look at Check Your Understanding number 6. So what's the wavelength of a wave traveling with a speed of 6 meters per second in a period of 3 seconds? So here we're already just given 6 meters per second. We're given a period, which we can use, a period of 3 seconds. What's the wavelength? We don't know yet. Okay, we don't know what the wavelength is. Now, we do have a formula, and the formula here is going to be, well, it's wavelength, we don't know what it is, so it's going to be wavelength is equal to the velocity times time. Okay, velocity times time, or the period. Okay, so it's going to be wavelength times 6 meters per second is equal to 6 meters per second times 3 seconds, which is going to give us here, easy peasy, 18 meters. So our wavelength in this case is going to be 18 meters. So meaning if these are our waves, the distance from crest to crest here is 18 meters. So from here to here is 18 meters. Okay, or again, it's even from trough to trough. So from here to here, the distance between this is 18 meters. Okay, and that's to Check Your Understandings, guys. So if you still have any questions for me, make sure you ask. If not, I'll see you in the next one.